In this video, we will be talking about Lab 5, the drag coefficient of a coffee filter. Now, I will be walking you through the steps of how to get your first row of data on the page 2 of your lab handout. So let's get started. So we're given that the mass of one coffee filter is equal to, let's place, there we go, 0.009171 plus or minus 0.0004586 kilograms. Now, I'm getting this number here by saying that some of the coffee filters are weighing more, some of the coffee filters are weighing less. The number I get here is based on the variance that I see from coffee filter to coffee filter. So now, since G is a constant, we're going to assume that it has no error associated with it. So now, I know that my weight of one coffee filter is going to be my number here, 0.009171, and that's going to be kilograms, times my gravity, which we know by this point in the semester is 9.8 meters per second squared. Now, if I do the math on that, I get that my weight is going to be 0.0090 newtons. So now what we have to do is find what is the uncertainty associated with that number. Well, let's do it this way. We've been doing it this way all semester, so let's do it again. I know, I'm going to be showing you the formulas, and you can do the math to prove it to yourself. But basically, the absolute uncertainty of my mass divided by my mass times 100 is equal to my percent uncertainty of my mass. And since we don't have any error associated with our G because it is a constant, I'm going to leave that error out. So, once I do the math on it, I find that my error for V is going to be my error for my weight is going to be percent uncertainty of my mass plus the percent uncertainty of G, which in this case is 0. So I'm going to cross that out, is equal to my percent uncertainty of my weight. And I find that this percent uncertainty is equal to 5%. Okay? So now I need to get this number back into an absolute uncertainty. And so I'll do that by this formula. Percent uncertainty in my weight divided by 100 times my weight is equal to the absolute uncertainty of my weight. And I find that that number is approximately equal to 0.00046 newtons. Now your number may vary depending on what you get. Okay, so next thing we need to do is need to find velocity. But first, let me go ahead and fill out the first row of my table. And I've already filled in my my weight rather. So now let's fill in our percent uncertainty, or rather our absolute uncertainty. So I'm going to say plus or minus. So this is my number, let me get a little highlighter here, 0.0090 for my weight. And my plus or minus I just calculated is plus or minus 0.00046 newtons. So let's go back up to the top here. Let's actually go to the next page. So in the next column, we need to actually figure out, one of the next columns, we need to figure out what our average falling speed in meters per second is. Well, we know, because we've seen it all semester, velocity is equal to distance over time. I could also write it as this, delta x over t. And I measured my distance, my delta x is equal to 10.4 plus or minus 0.1 meters. Now I'm getting this number by assuming that, well, maybe my hand wasn't at this location. Maybe my hand was at this location the first time I dropped it, and maybe it was at this location the second time I dropped it, and well, maybe it was at this location the third time I dropped it. So I'm saying plus or minus 0.1 meters for my uncertainty. Okay, so we have our delta x. We know our t because we got our t from our average, right? We did 3 trials and we got an average. So for me, my average was 8.01 plus or minus 0.4 seconds. And this is going to come from your max minus your min divided by 2. Okay? Alright, so I do the math. I say 10.4 over 8.01 is equal to my velocity, which in this case is equal to approximately 1.30 meters per second. Okay, so now we need to find the error associated with this. So what's the error on my velocity? Well, as I previously shown, we can go to percent errors by saying the absolute error of a quantity divided by that quantity itself. So in this case, we'll say the absolute error of my delta x divided by my delta x times 100 is equal to my percent uncertainty. I'm going to skip a few steps here. I'm going to say that I know how to get my percent uncertainty from my delta x, and I know how to get my percent uncertainty for my t. And I do this formula. I say the percent uncertainty of my delta x plus the percent uncertainty of my t is equal to my percent uncertainty of my velocity. And when I do the math on that, I find that my percentage is 6%. Okay, and I actually want to save this number for later. Let's see, I'm going to grab my little pen here. Save for later. So I'm going to keep that 6% in mind. But for now, I'm going to take that 6%. I'm going to divide by 100, just like I showed earlier. I'm going to say my percent uncertainty of v divided by 100 times my v is equal to my absolute error on the v. Right? So if this is my v, I will say 6% divided by 100 times my v, and I get my number is, let's see here, I have my number as 0.0775 meters per second. Okay, so now let's fill out our table. Let's put this in our little table here. And I told you just a second ago that my time was 8.01 seconds plus or minus 0.4 seconds. And my average velocity, which I just calculated, is 1.30 meters per second plus or minus 0.0775 meters per second. Now we need to do our velocity squared. So now I can do my velocity squared, the actual number for velocity squared. I'm going to make a little column here so I don't use another page. My velocity squared is just going to be equal to my velocity, which I'm going to highlight here for you. My velocity right here, squared. It's as simple as that. So I'm going to take that number and square it, and I find that my number, when I square, sorry, not our error, excuse me, my v right here, when I take and square that number, this number right here, I get 1.69 meters squared per second squared. But now we need to figure out the uncertainty on it. So now let's take this 6% that I have marked here, and let's do, since we've done this before, I'm going to skip a few steps, but basically, if we have a square, since we are squaring our velocity, if we have a square, we need to multiply our percent uncertainty times 2. And so since I only used my velocity, I need to now square this percent uncertainty. So now, let me do it this way. 2 times, because of the square, my percent uncertainty, which I have here, 2 times 6%. And I'm going to do the formula like I have here. I'm going to say 2 times my 6% divided by 100 times my v squared, 1.69 meters squared per second squared. And I find that my answer is going to be, let's see, plus or minus 0.201 meters squared per second squared. So now I'm going to go ahead and fill out my little page here using these numbers that I just got. This one right here and this one right here. I find that my velocity squared is 1.69 meters squared per second squared, plus or minus what I just calculated to be 0.201 meters squared per second squared. So that concludes this video. I will be making another video very shortly that describes how to do the second part of this lab, which is graphing the data and finding a best fit and all that. So be on the lookout for that. And if you like this video, give it a thumbs up, and please let us know if you like these videos. It'll help keep making these videos for you guys. See you in the next one.